Welcome back to Statistics for Business 1. I'm Shankar, your course instructor.
And I'm his historian, Liza.
We are now looking at a dataset on gasoline prices which we have downloaded from the World Bank website. In our last segment, we showed how to calculate summary measures for grouped data.
I just couldn't believe how close they were to the actual numbers.
You got that right. In this segment, we will go over the shape of the histogram and try to qualify it using some numerical measures.
You're always measuring things.
Because it's a quant course, Liza. How else will you distinguish between two large data sets?
With my eyes, of course.
You mean you can easily spot differences between two histograms? I doubt it.
I was just joking.
She does. So let's talk briefly about moments. If we look at any column of numbers, the first raw moment is nothing but the mean of the numbers. You know by now that the sum of the deviations of these numbers from their mean is simply
0, 0, 0.
Awesome. And that's why we will go with a squared deviation and average them to get the variance. We call this variance the second corrected moment, and here's the symbolic formula which we will call mu2 or nothing but sigma squared.
So, can we cube the deviations?
Why not? Of course we can, and take their average. We will call it mu3. Now this is something useful to statisticians because one way to quantify the shape of a distribution is to calculate this amount mu3 divided by sigma cubed, which we will call skewness. Just use skew in spreadsheets. And unlike variance, which is always positive, skewness can be positive or it can be negative. I must caution you that there are other formulas for skew also. Before we go ahead with calculating skews for our data columns, here's how we interpret them. Suppose you construct the histogram for a variable and then you have a tail pointing towards the right, then it is positively skewed. So Liza, can you talk about a variable that is positively skewed?
How about the salaries at a private company?
Wow, that's fantastic. More people make lower salaries, whereas a lucky few make the big bucks.
What's so positive about that?
I don't know. So Liza, how about you come up with a data set that has negative skew?
How about something whose price went up and is on the way down now? I know, like the price of vanilla.
This is a common mistake. You see, the y-axis does not take anything other than a frequency when you're looking at histograms or distributions. I would say the demographic age profiles for several countries are skewed negatively. Now, how about a business data set that has a negative skew? Well, we need to go no further. Let's just use the skew function on our spreadsheet of gasoline prices. So let me go ahead and calculate the skew using the skew function. So I have skew of everything from this cell all the way down, which is Control Shift down arrow or Command Shift down arrow in the Mac. And what do I have as my skew? Minus 0.14 for the year 2008. Now, how do I calculate skews for the other years? It turns out that the skew has been increasingly negative between 2008 and 2012. Now, instead of trying to imagine what is happening, why don't we stick the three histograms side by side and examine them? These histograms are what I have created using R. So, I'll ask you to look at that carefully and tell me what you will notice. At the extreme left of this picture, the skew is quite low at minus 0.14, that is for 2008, whereas it's almost 3 times as high on the right at minus 0.41. The leftmost histogram is the most symmetric if you notice carefully. Forget about whatever is on the extreme right there. While the tail makes itself felt in the rightmost histogram. Do you get my point?
How about the fourth power?
Why not? We have what is known as kurtosis, which is given by mu4 divided by sigma to the power of 4. Now the spreadsheet function for this is simply kurt. Again, this says something about the shape of the distribution, how pointed it is. But we must understand the normal distribution a little more to appreciate this measure. Let's just say that finance people often worry about kurtosis. We might have been able to calculate the skew for a data set, but how is it relevant to us? If there's a lot of skew in a data set, then we have to be careful about the kind of statements we'll make about what is the average value. Now it's a common misconception that the average or mean and the median values are sort of close to each other for a data set. That's wishful thinking. So we have designed a caselet just for you to explore such a faulty line of reasoning. And with that, we come to the end of this segment.